Boys and girls, this is Mr. Manise here again with another super exciting video, and this is one of my favorite videos maybe in the entire geometry curriculum because you guys know I'm real big on the real world and how we apply this stuff that we're learning to outside these walls that we call schools. So we're going to look at the real world application to quadratics that we've been working on now for quite some time. So I'm going to dig into some of these real world problems and show you both how to do this manually the long way and also how you can use your graphing calculator to use the shortcuts to do this with the calculator. Of course, you guys know I'm real big on that. Yes, you need to understand what's going on behind the scenes. You need to know what your calculator is doing, but at the end of the day, we have technology as a resource in our hand that you can use. It's allowed on the EOC, so I will never tell my students that they can't use a calculator. You guys have probably heard me mention that I would do engineering problems in college that would take several hours to do one problem, and then I find out there are software programs that'll do it in 5 minutes. That doesn't mean you don't need to know how to do the problem, but you need to understand how to input the data, how to interpret and analyze the results, even though we have software and technology resources that will make our lives much more efficient. So anyway, let's go ahead and jump into some of these problems. And I don't know, there's just a random piece of paper. It came from somewhere else. I'm sorry, I don't know where that came from. But anyway, let's take a look at some of these problems. And before I jump into this, I want to kind of just show you guys just a visual of what we're looking at when they're asking us to do these problems. They're basically, guys, only going to ask you for one of two things. It's really, really quite simple. If I draw myself a little picture here, and we're talking about, you guys did the marshmallow catapult project. That was awesome. Maybe we're launching a marshmallow in the air. Maybe we're shooting a firework in the air. Maybe we're throwing a baseball or hitting a golf ball into the air. So we have a quadratic. It's going to go up. It's going to reach some maximum. It's going to come back down. So basically, guys, they're going to only ask you for one of two things. They're either going to ask you, what is that spot right there? What is that red dot? And what is the significance of that red dot? Well, that is simply my vertex. Okay, that's going to be the maximum height in most cases with these real world application problems. Or instead of asking for the vertex, the maximum height, they may ask you for the green dot. What is the significance of that spot? That's the spot where I am crossing the x-axis. That is simply my x-intercept. Okay, so maybe they want to know, how long does it take until it hits the ground? How far does the marshmallow go? So that's it, guys. They're either going to only ask you for the red dot or the green dot. Okay, and most of these problems, we're going to have time. Scoot this up a little bit. We're going to have time on the x-axis, and most of the time we're going to have height on our y-axis. Okay, so that's basically how each of these problems work. Okay, so let's go ahead and jump into a couple of these problems. So I'm going to do actually the same exact problems that we did in our little gallery walk around here. So one of the problems that we were looking at had to do with golf. So I'm looking at this problem here. So before we even start putting stuff into our graphing calculator, I got to figure out, what are they asking us? Were they asking me for the red dot? Were they asking me for the green dot? So here we go. I got the height in feet of a golf ball hit into the air is given by the equation h equals negative 16t squared plus 64t, where t is the number of seconds elapsed since the ball was hit. Okay, and it's asking me, how long does it take for the ball to hit the ground? So let's go back to our sheet here. How long does it take for the ball to hit the ground? Okay, so I'm hitting the golf ball. The golf ball is going up. How long does it take to hit the ground? Am I trying to find the red dot, or am I trying to find the green dot? I'm trying to find this guy right here. I'm trying to find how long, the time, how long does it take until it comes back down and reaches a height of 0. So I am trying to find the green dot, which in our case is the x-intercept, the root, the 0, the solution, the answers, however you want to think about that. All those words are synonymous. They all mean the same thing, okay? So I'm going to show you guys how to do this manually, and then I'm going to show you how to use your graphing calculator to solve this. Okay, so I'm going to just kind of put this, I'm going to put the sheet kind of here off to the side. Let's get our graphing calculator back out. So I'm going to go ahead and write, I'm going to have to write this in pen a little bit smaller. So here's our equation. H is equal to negative 16t squared plus 64t. Okay, now when we're using a calculator, your calculator is not going to recognize t's. So instead of h's and t's, we can use x's and y's. So I'm going to change the height Okay, I'm going to change that to a y, and that's going to be equal to negative 16x squared plus 64x. Okay, now if this is a quadratic that I'm trying to solve, remember we have 7 different ways to solve a quadratic equation. You got to figure out what is the best way to solve this. Well, to solve this, I'm trying to figure out how many seconds does it take until it hits the ground. Okay, well, if I'm trying to figure out how long it takes until it hits the ground, what does y have to be? What does my height have to be? It has to be 0, right? Okay, I want my height to be equal to 0. My height is going to be equal to 0 in 2 spots. If I put this back up here on the screen here, the height's going to be 0 at that spot where I started the golf ball, and then I hit it, and there's going to be 0 at the green dot, right, when it comes back down and hits the ground. So it's going to be 0 at 2 spots. So to solve my quadratic equation, I need to set this guy equal to 0. I'm going to put the 0 on the right-hand side. So I have negative 16x squared plus 64x is equal to 0. Now, how do you want to solve this? And if you say the quadratic formula, then I'm going to go make you sit in the corner. Okay, because there's a much easier way to solve that. First of all, I only have 2 terms. So I'm already thinking to myself, okay, maybe it's a square root method, maybe it's a GCF. In this case, I don't have a C term, I don't have a constant. I just have an x squared term and an x term. Okay, so this is GCF all day long. I can pull out, and the front term is a negative, so I'm going to factor out a negative 16x, because both terms have an x. What would that leave me with? I basically have to divide each of these terms by negative 16x to figure out what's left over. And that's going to leave me with an x, and then 64x minus 16, that's going to leave me with minus 4. Okay, so now I have negative 16x times x minus 4 is equal to 0. Okay, our 0 property product says if I multiply 2 things and get 0, one of these bad boys has to be 0. So I'm going to set each one equal to 0. If I set negative 16x equal to 0 and divide by negative 16, then yes, with my GCF, I'll always get one of my answers is 0. Okay. All right, now if I set the other one equal to 0, if I set this guy equal to 0, what do I do with the sign? I flippy flip, right? So x is going to be equal to 4. So I get 2 different answers. I get 0 and 4, but we're talking about time here. The golf ball goes up and it comes back down. Obviously at a time of 0, it's at a height of 0, so this is going to be the more reasonable answer, right? After 4 seconds, it's reasonable that my golf ball is going to come back down and hit the ground. So my final answer is 4 seconds. Okay. Now that's how to do it manually, solving the quadratic. Now if I want to use my calculator, then I'm going to simply type in my same function, but again, instead of h's and t's, I'm going to use x's and y's. So on my calculator, I'm going to press y equals. So let me go back to the main screen. I'm going to press y equals, and I'm going to type in my equation. Now, actually, let me back up for a second, because I've seen a lot of errors in syntax and bound errors and dimension errors, window errors. Let me just kind of address some of the errors that you may find when you're typing in these functions. The first one is a syntax error. If I type in this minus button right here instead of a negative, watch what happens when I type in a minus. Minus 16x squared plus 64x. I'm going to get an error when I try to graph it because your calculator doesn't understand what minus 16x is. That needs to be a negative, so make sure you press the negative button right here. Okay. All right, so that's one error. Another error that I see sometimes is with these stat plots, especially since we've been doing the catapult projects with the calculator procedure. So if you press second stat plot, you want to make sure all these are in the off mode. Okay. If I go to y equals, I don't want to see any of these highlighted. These need to be off. That's another error. The other error is with your window. If I go to my window, the main default setting should be going from a negative 10 to a positive 10 on the x value, negative 10 to a positive 10 on the y values, on the y-axis. Okay, that's what the zoom standard does for us. When I press zoom and I select 6, I get back to that standard window where I'm going negative 10 to positive 10 and negative 10 to positive 10. So those are some errors that you may run up against. Okay, so let's type in y equals, and let's go back to our function, negative 16x squared plus 64x. Okay. Now, the first thing I want to do is I want to graph it and see what it looks like. Does it even show up on my graph? Can I see the graph? I can in this case. I'm starting here at the origin. My graph is going up. Now notice I can't see the top of the graph. It's going all the way off the screen. It's going up here, all the way off the screen, up, 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 up. Okay, just kidding. All right, so it's going all the way off the screen, and it's coming back down here. So I got to ask myself, am I trying to find the x-intercept? Am I trying to find the vertex? trying to figure out how long does it take for this ball to hit the ground. I want the x-intercept. I want that guy right there. So I'm trying to use Mr. Spidey to do my left bound, right bound to find that x-intercept. Another thing that I saw students have trouble with during class is, well, Mr. Manise, I don't know where Mr. Spidey is. I can't see him. Where is he? He's off the screen, okay? Well, before I even get started with Mr. Spidey, I want to get an idea of about where does he need to be. So I can just count 1, 2, 3, 4. I already know that the answer is 4 because I did it manually. But if you're doing the calculator first, you need to get an idea, okay, I'm going to be somewhere around 4. Now to find Mr. Spidey, I'm going to go second, calc. Now here you got to make a choice. All right, am I trying to find the 0 or am I trying to find the min, the max? I don't care about the vertex. I want the x-intercepts. I'm going to select option 2 for the 0. Okay, now here we go. So students are like, I can't see Mr. Spidey. Where is he? If you look down here at your coordinates, whatever your x and y coordinates, that's where Mr. Spidey is. Okay, right now he's sitting at an x of 0 and a y of 0. So he's sitting right here at the origin. And I see that because I can literally see him blinking. But sometimes when you graph it, he's off the chart and he's off the graph and you can't see him. So since I did a kind of a pre-estimate, I counted, I know that he needs to be somewhere around an x of 4. So he's at 0, so I need to click to the right, and I'm going to keep my eye on this value right here, this x coordinate. And when I get close to 4, I'm going to slow down because I know that's where he needs to be. So I'm going to keep clicking, keep clicking, keep clicking. Okay, I'm starting to get close to 4, so I'm going to slow down a little bit. Slow down. Do I see him? Don't see him yet. There he is. Okay, so there's Mr. Spidey. The calculator wants a left bound. The calculator wants a spot to the left of this x-intercept where I'm below it. So technically I'm not to the left. Technically I'm to the right of it. I'm barely to the right. I don't need to be there. So I'm going to back it up. Back it on up. So I'm going to press the left button and back up. So now Mr. Spidey's back up here somewhere. I can't see him, but he's up here and he is to the left. Okay, so that's good. So I'm going to press enter. Now notice my calculator wants a right bound. My calculator says, okay, I got you, Mr. Manise. Now give me a spot to the right of where you want me to find. I say, okay, Mr. Calculator, I'm going to go one click to the right, and I'm going to bring Mr. Spidey back down here where I can see him. He's below this spot, which technically he is to the right, so that's good. So I press enter. My calculator says, Mr. Manise, are you ready for me to guess? And I say, yes, sir, Mr. Calculator, I'm ready for you to guess. I'm bracketing that spot and this spot, and I'm telling the calculator I want you to find the intercept between these two bounds that I just gave you. So I'm going to press enter for a third time, and lo and behold, my calculator spits out 4, 0. Okay, but that's not the answer. The answer to this question is not 4, 0. The answer to this question is how long does it take for the ball to hit the ground? Okay, and the answer to that is simply this x coordinate. Okay, this spot right here. So it's going to take me 4 seconds to hit the ground. But again, we already knew that because we did it manually. Okay. And I'm begging you guys on the test, I'm begging you to use your calculator, use Mr. Spidey, especially if you have to use the quadratic formula or something pretty complicated to find the x-intercept. To me, it is so much easier to do this on your graphing calculator, although you do need to know how to do this manually, okay? All right, so let's jump in and let's do some more. Put this off to the side, and let's do this problem right here. How about this one, the fireworks problem? Okay, so this one says, fireworks are discharged vertically upward from a height of 4 feet above the ground. Right? Its path is given by this equation. H is in height in feet and T is in seconds. Now look, pay attention. Read this question carefully. When, that's time, when will the firework reach its maximum height? That's question number 1. Question number 2 is, okay, after you find when, I need you to tell me actually what is that actual height, okay? All right, so let's go ahead and write down our equation. Let's go back to y equals. Let's clear that. So I'll write my equation down here. It's h is equal to negative 16t squared plus 160t plus 4. Now once again, I'm going to use x's and y's. So y is equal to negative 16x squared plus 160x plus 4. Okay, now if I want to solve this quadratic manually, okay, let's do that. I'm going to do that a couple more times, and the rest of the problems I'm just going to use with my calculator, because I know some of you guys do not have your graphing calculator yet, so you do need to know how to do this manually. I'm going to set this equal to 0, so I have negative 16x squared plus 160x plus 4. I'm going to set that equal to 0. I need to solve. Okay, so how do we want to solve it? Now, if you're trying to find, let's go back to our problem here. Let's go back to our problem. When will the firework reach its maximum height, and what is that actual height? Okay, so let's go back to the original sheet that I wrote down here. What are they asking us to find? Are they asking us to find the vertex, or are they asking us to find the x-intercept? They want to know the maximum height. So in this case, they're actually asking us to find the red dot. Okay, they're asking us to find the vertex. Okay, so if you're trying to set this equation up and set it equal to 0 and solve, you can do that, but what you're doing is you're finding the x-intercept, and that's not what we want. We want the vertex. Okay, so to solve for the vertex manually, I'm going to have to use this little equation here. The x-coordinate of my vertex, if you guys remember this little mini equation, is simply negative b divided by 2a. You guys remember that? Okay, so what is my b? Okay, my b is 160 and my a is negative 16. So I'm going to plug this into my little equation. So I have negative b over 2a, so negative b, so negative 160, divided by 2 times a, which is negative 16. So that's going to be negative 160 over negative 32, and that comes out to be 5. Okay, so the x-coordinate of my vertex is 5. It's going to be 5 comma something. Okay, how do I figure out the y-coordinate? I got to take this x-coordinate, I got to take this guy and plug him back in for my x's, or for my t's. Okay, so if I plug this back in, I'm going to get negative 16 times 5 squared plus 160 times 5 plus 4, and if I work out that math in my calculator, I get 404, which means manually the coordinates of my vertex are going to be 5 comma 404. Okay, but what does that mean? 5 and 4, is that 5 donkeys eating 404 cheeseburgers? What is that? Okay, we're talking about, in this problem, we're talking about fireworks going up and coming back down, right? So the 5 is going to be the x-coordinate of the vertex. So that means 5 seconds. After 5 seconds is hitting a maximum height of 404. Okay, so the 5 is for seconds, and the 404 is my height in feet. Okay, that's how to do it manually. Now, again, I am a big proponent of using the graphing calculator, so let's do it the easy way. Let's plug in negative 16x squared plus 160x plus 4. And the first thing I want to do is graph it. Let's just see where we stand. Let's see if we can even see it on the whole screen, because you might not be able to see it on the screen. Okay, so in this case, it is kind of hard to see. I can kind of see a part of it. So in this case, I want the vertex. Okay, now this is a beautiful thing about the graphing calculators. I love these things. They can do all kinds of really cool stuff. I don't care about the x-intercept. I can't hardly see it over here, but I don't care about that. I want the vertex way up here. Okay, the fireworks going up, reaching a maximum height, and it's coming back down. If I want to zoom in on the vertex, I can press zoom, and I can scroll down to option 10, which it actually shows as a 0, but that's option 10, zoom fit, and I'm going to press enter. And your calculator, it's beautiful, your calculator will zoom in on the actual vertex of your graph, so it shows you exactly where the turning point of the roller coaster of the graph is. So now I'm ready to use Mr. Spidey to go to the left of the vertex and to the right of the vertex. So I'll go second calc, but I don't want the 0. I don't want the x-intercepts. I want the max or the min. Okay, and in this case it's turning over, so that's a maximum. I need to select option 4. Okay, so now there's Mr. Spidey. I can see him. So I just need any spot to the left. That's good right there. Press enter. Now I need a spot to the right of the vertex. So I'm going to scroll over, over, over. Give yourself plenty of room. Don't try to cut it close. Go way to the right of it. So you're guaranteed. That's good right there. I'm guaranteed I'm to the right of the vertex. Press enter. Yes, Mr. Calculator, I want you to guess. And lo and behold, it spits out 5 comma 404, which we already knew that because that's what we got when we solved it manually. So once again, it's going to be 5 seconds for the time, okay? 5 seconds for the time with a height of 404 feet, okay? And by the way, if my vertex is 5, 404 and it takes 5 seconds to reach the height, how long will it take till it hits the ground? It's going to be double that, right? So in 10 seconds, it's going to come back down and hit the ground. All right, so let's try another problem. Oh, I got a good one. Here's a good one. I like this problem. This is a really good problem right here. I like this problem. All right, let's try timber. So we're in the middle of a tropical storm at the Empire State Building. Don't ask me why we're doing that. Sounds kind of crazy. And an antenna broke loose from the roof of a building 144 feet high. The antenna's distance d in feet above the ground after t seconds is given by the equation. Pay attention to the question. Determine when the antenna will reach the ground. So those are the trigger words I'm looking for. I'm looking for the word ground. I'm looking for max height. And that tells me whether I'm trying to find the vertex of the x-intercept. When I see the word ground, I'm already thinking to myself, okay, ground. I'm hitting the ground. I can't be the vertex because that's up high somewhere. Ground. I need to find the x-intercept. Okay. All right. I'm not going to do the manual version anymore for these last couple of problems. I'm just going to kind of show you guys how to do it on the graphing calculator. Okay, so let's go ahead and grab another piece of paper here. Let's go ahead and write down our equation. Let's go back to y equals on the calculator. Let's write down the equation. I have d is equal to negative 16 t squared plus 144. So again, let's turn this into x's and y's. Y is equal to negative 16x squared plus 144. Okay, so what are we trying to find? We already said ground. Okay, so I'm trying to find the x-intercept. So let's go ahead and graph this. Let's go back to negative 16x squared plus 144. And let's graph it. I want to get an idea. Now notice here that my window is kind of jacked up from the last problem. Okay, I don't want that. Let's go back to zoom standard. I want the standard window. So go zoom 6. And let's get back to our standard window and let's see if we can see the graph. Okay, that's not too bad. I can see both sides of the graph. Okay, so once again, it's going way off the screen. I don't care about the vertex in this problem. I want the x-intercept. I want that guy right there. So once again, I need to kind of get a feel for how far does Mr. Spidey need to go to the right. Well, if I count, I can count 1, 2, 3. Maybe it's exactly 3. I don't know. Maybe it's 3.2. I don't really know. But that gives me an idea of where Mr. Spidey needs to be. So let's go second calc. And I need the 0 this time because I'm trying to find the x-intercept. So I'm going to select option 2. Okay, my camera's a little bit zoomed out here. See if you can focus in. Okay, so here's Mr. Spidey. So where is Mr. Spidey right now? He is sitting at 0, 144. He is way up here. There goes the focus. Thank you, focus. He is way up here. He's sitting at 0, way off the graph, all the way up here at 144. I need him at an x of about 3. So I'm going to click to the right until I get close to 3, and then I'll slow down a little bit. Okay, slow down. Here he comes. There he is. Okay, good. That works out nicely. He is just to the left of the x-intercept. That's good. Press enter. Now I need to move him to the right. I can't see him, but that's okay. I know he's on the other side of 3. He's to the right of 3. Press enter again, and sure enough, it's exactly 3 in this case. So my x-coordinate is 3, 0. What does that mean? 3 pineapples? What is that? Okay, we're talking about how long does it take until it hits the ground. So the answer is 3 seconds until this antenna that broke off until it hits the ground. Okay, let's try another one. Let's try the kangaroo. Okay, so the kangaroo equation was y equals negative 0.267x squared plus 3x. Okay, so already in terms of x and y, so let's go ahead and graph it. Negative 0.267x squared plus 3x. Okay, now again, let's read the problem. What are we trying to find here? Kangaroo. What is the highest the kangaroo jumps? Highest. There's the trigger word. I want the maximum height. So in this case, I want the vertex, which should be pretty easy to find because I can use the zoom fit feature and zoom in right on the vertex. So let's graph it. Oh, okay. All right. In that case, I can actually see the vertex. I don't need to zoom in on it. I know that spot is what I'm trying to find. So let's go second calc. That's a maximum. And now I need to use Mr. Spidey. There he is, right there at the origin. I just need any spot to the left. That's good. Press enter. I need any spot to the right. That's good. Press enter again. Bam. There is my vertex. Okay, now hold on a second. I got 5.62, comma 8.42. Which one of those do I use? Okay, I want to know how high does the kangaroo jump? Which one is it? Do I want the x coordinate or I want the y coordinate? I want the y coordinate. I want to know how high does it go. This is the guy who doesn't care anything about the x coordinate. The maximum height is going to be 8.42, whatever the units are, which in this case are feet. That kangaroo is jumping 8 feet, which, by the way, that is a kangaroo on steroids. I could still probably dunk over this kangaroo, but 8 feet, that's pretty high. Okay, so let's move on to the last one. Mr. Rocket. We are launching rockets in the air. Here's the equation for the rocket. When, here's a trick word, when will the rocket hit the ground? Okay, ground. So that lets me know I am looking for an x-intercept. How does it come back down and hit the ground? Okay, so let's write last one. Stay with me. You can do it. Y is equal to negative 16x squared plus 150x plus 30. Okay. And once again, if I want to solve this manually, I'm trying to find the ground. I want the x-intercept. I would have to set this quadratic equal to 0 and solve, which in this case, I'd probably have to use a quadratic formula because I can't factor. Those are some pretty big numbers. There's no GCF. 16 doesn't go into 30. 8 doesn't go into 30. 4 doesn't go into 30. That's quadratic formula all day long. Thank goodness we have the calculator. Okay, so let's plug it in. Negative 16x squared plus 150x plus 30. And let's graph and see what we got. Okay, so I can see my graph. Okay, I can barely see it on the right over here. So I need Mr. Spidey over here to this side. So let's get an estimate. Let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like it's somewhere between 9 and 10. So let's go grab Mr. Spidey. Second calc. I want the x-intercept. I want to select the 0. Mr. Spidey is sitting here at 0, 30. He's way off the top of the screen, way up here somewhere. I just need to go ahead and click, and I'm just going to hold it down until I get somewhere close to 9. And then I'll slow down. Okay, so start slowing down. Getting close to 9. Still don't see him. Still don't see him. There he is. Okay, now technically, now this is close. Now he's barely below the x-intercept, which means technically he's to the right of it. That's not what I want. So back it up. Back up. One click to the left. Mr. Spidey's sitting up here somewhere. I can't see him, but I know he's up above. He is to the left. That's good. That's the left bound. Press enter. Let's go one click to the right. Let's get him back down here. That's good enough to be to the right. It's close, but it's good enough. If you're not comfortable with that, go ahead and go one more click to the right. That's fine. Press enter. Do I want to guess? Yes, I want to guess. And it spits out my x-intercept of 9.57, comma 0. Okay. All right, so what do I use here? What is the meaning of these numbers? Okay, when will the rocket hit the ground? Okay, it's going to hit the ground after 9.6 seconds. Okay, now one thing I am real big on is asking myself, does this answer make sense? Man, I hope this is not a full-blown NASA or true rocket with astronauts, because this rocket's going up and an explosion, come back down after 9.6 seconds, and everybody disintegrates and spontaneously combusts into flames. That's just not cool. We're probably talking about a toy rocket. We're talking about a firework, okay? We're not talking about a true NASA space shuttle, okay? 9.6 seconds, that sounds reasonable. I buy that, okay? So anyway, that's it for this. One more thing I want to show you guys. One more thing. If you're having trouble with Mr. Spidey, if you don't like the fact that you're having to do this, the whole click thing, you know, I can't see Mr. Spidey. I'll show you one more beautiful trick with your graphing calculator. I have not shown you guys this yet. But if you come across this, you can use it. Press zoom and select number 1. Select zoom box. Okay, and what you're telling you, now you can move wherever you want to move with the little cursor there. You're going to literally form a box around where you want to zoom in. So once I'm ready to make my box, I move my cursor there, I press enter. I'm going to drag my cursor to the right. Don't press enter, drag it to the right, and then I'm going to drag it down. And I'm literally going to form a box around where I want to zoom. and then I press enter. And now your calculator will zoom in right on that spot where you wanted to find. And now I can do Mr. Spidey. Second calc, find the 0. And now notice every click is much less because I'm zoomed in. Instead of one click moving like two units, one click doesn't move very far. So now I can zoom in with Mr. Spidey and get closer to. So now I'm zoomed in a little bit more. It's easier to see where Mr. Spidey is around the 9.6 value. But anyway, that's it for this lesson, this video, guys. I hope you enjoyed it. And I got one last little problem here for you I want you to take a look at. And we'll wrap up. And yeah, that's it. All right. Thanks, guys. And we'll see you on the next video.